Hello everyone. So our next circuit was op-amp as an integrator. So this is the circuit, and if I draw this in PSpice, so this will be just like this. So anyway, the other components are almost similar. Here I have needed another component, capacitor. Probably you didn't use it in previous experiment. Anyway, to take capacitor, you can click on here, get new part, and then if you write C, then this one is the capacitor. So you can place, and then you can place it where you need it, and then to change its value, you just need to double click this on N, and then you can provide it 0.22 U, then F, that will give you 0.22 microfarad. So by this you can have this 0.22 microfarad capacitance, and other things are similar to our previous experiment, so I'm not mentioning all of this. So let's move on. So in this circuit, the procedure is written. First we need to construct the above circuit, and the VI should be a square wave, and to do this I already demonstrated these parameters. So to configure this parameter in PSpice, you need to double click on this, and then here I have written here, so VI equal to 5 minus 5, then I have saved it, then 5 saved it. So that's like this, minus 5, that means I have written minus 5 and then save attribute, and then again plus 5. So when you will take this part as first, obviously these all values will not be there. So you need to put on values one by one, and you need to save it, and at the end you need to press on OK. And the parameters I already mentioned and I already discussed. And next you need to run the simulation along with bias point detail. You need to simulate in transient mode. So in previous experiment you already noticed that in order to show wave shape we need to simulate in transient mode. So you need to click on this setup analysis, then this transient. Initially by default it is unchecked, so you need to click on, that is you need to check it transient, and you need to click on this transient, and here this final time, so for how many times you want to perform this simulation. So if you can remember our circuit, so here the period is 2 milliseconds. So if I want to observe 3 pulse, that is 3 period, then obviously the final time will be 6 milliseconds. So I can provide it 6 milliseconds. Or if you want to observe for let's say 5 pulse, then you can provide it as 10 milliseconds or other things. So anyway, next I want to click on OK and then close. And obviously to observe the voltage, I have taken this, this voltage marker. So I have given it on here and another is here. And then all I need to do is to click on this, simulate. So when I click on this simulate, so it is now simulating and it will here. So the wave shape is generated. So if you notice this red wave, that is the V at Ri. So in the circuit here Ri, so this one actually V at Ri, and this one is actually V at Ro. So in the circuit Vri, and this is the actual output voltage, that is the R output. Anyway, so this one is the input voltage that I have supplied as our rectangular wave. And in the lab sheet demonstration I already mentioned that if you provide a rectangular wave, and the wave shape you will get will be a triangular wave. So if you notice, it is a triangular wave, but there are some anomalies, let's say in this region and also this region. This is because as I already told you in the lab sheet demonstration, that the circuit we are operating, it's not perfectly practical. We need to incorporate other components in this circuit, but this is the simplest circuit to perform the integration operation, and that's why it is not perfect actually. And we have a capacitor, and you know that capacitor, there are time constant and other stuffs associated with it, and that's why these are not perfect, but I can say you have a sense of how the output will be. So we have provided a square wave, uh, rectangular wave, and we have got a triangular wave. And if you notice, so for first period it was positive 5 volt, right? And the voltage you have found in the output, it is negative. Why? Because in the lab sheet, if you notice the output expression, it was a negative sign. Okay, in the lab sheet, so here it is a negative sign. That's why the triangular wave is the inverse of the input rectangular wave. So obviously you should consider the wave shape. For the report question, you need to write all the student IDs of your group in a text box, just like our inverter circuit I already demonstrated in previous video. And then you need to submit a screenshot of the schematic and the wave shape. That means I asked you to submit this. So this is the wave shape, and along with this I asked you to submit this schematic that you have drawn. And this schematic, you obviously need to write the your group members student ID in a text box, and then you should take the screenshot.